before we continue with this lesson, I suggest you to practice worksheets 1C and 1D about the normal stress. So now the topic is shear stress. Shear stress. And for normal stress, we call that is sigma, and for shear stress, we call it tau. Spell out tau. If we have a simple beam, have a load 2P apply, then we have reaction P and P if it's symmetric load it apply on that member. So if we make a transverse cut on that member, and at the multi-force member, we consider the left segment of the cut. Then we have the load P, and it's exposed to the shear force V. We have a normal force and internal bending moment, as we already talked about, and that applies for a transverse cut. So as you can see, use the equilibrium equation in x direction, we can see that the shear force equal to V, and that will be equal to the load P if we apply the equilibrium equation in y direction. And that shear force will create a shear stress. And shear stress is tau, so let's talk about the characteristic of tau. For tau, it is parallel to cut face, so that different from the normal stress is perpendicular to the cut face. Tau shear stress is parallel to the cut face, and it also in the same direction of the shear force. So tau is in same direction as shear force V. And with the equation, we will have tau equal to force, shear force, divided by the area of the cut face, as we already defined. And in this case, the shear force equal to P, so it will be P over A. So that is the shear stress. The shear force creates the shear stress, and it measures also the intensity of the shear force per unit areas, and in this case the areas is A of the cut face. So that is the shear stress. So before we go to practice worksheet 1E, I want to see the difference, want to show you the difference between the single shear versus double shears, that you may see that in problems in the homework 1. So let's see the single shear versus double. So what the difference here, that this finger I copied from our textbook, chapter 1. So as you can see, the on the left, that basically a single shear. So we have two load applied on to member A and B, F and F apostrophe, and that will create a shear on the bolt CD, and that we call that a single shear. That one is a single shear. in opposite on the right side, we also have a force F and F apostrophe apply on member A and B, and that tend to separate the member EG or HJ, as you can see, and at two position, have here, have there, have here, there. Unlike the single shear, as you can see, it's only one separation. This is two, and that we call it a double shear. So what is the difference between the single shear, as is the force applied and create a shear on the bolt CD on the left, and the double shear as it apply on the bolt EG or HJ on the right? What's the difference? So let's work on the free body diagram of the bolt. As you can see, if we separate the bolt CD on the left, so you have F and F apostrophe in that direction. And then to find out the internal force, we have to cut the member through that one here. The cut is E apostrophe. And then the internal force, in this case the shear, because it parallel to the cut face, P, and with the equilibrium here, you will see P equal to F for the single shear. And for the double shear, so if we consider the bolt HJ, for example, it is similar to EJ, right? But now let's talk about HJ. So you have a force F go to the right on that member in the middle, so that you can see the force F here, and that go back to show to on the diagram here, and then the free body diagram there. And then we have create a two force on member C, and that call it FC, and member D, it call it FD, apply on the bolt as well, and that tend to separate at two cut, KK apostrophe and LL apostrophe, two cut there. So that create a two shear force, and that because it's symmetrical, that should be the same P and P, two shear force on those two cut area. And with the equilibrium equation, if we sum up all the force in the very bottom right of that free body diagram, you will have the P in X direction is equal to F over 2. And that's the difference between the double shear and single shear. So at the shear force P equal to F on the single shear, so as you can see, for that scenario, single shear, you will have tau for single shear equal to P over the areas of the section, cross-sectional areas of the bolt. Unlike tau equal to P over A for the single shear, for the double shear, as you can see, tau equal to P over A, so the same shear force, but P equal to F over 2, so it will be equal to F over 2A. What does that mean? The shear stress in the double shear is only half of the single shear. At P equal to F on the single shear, it will be also equal to FA. So that's the difference between the double shear and single shear. The shear stress reduced half in the double shear compared to the single shears. So that practice problem worksheet 1E, so that you can see the shear stress